So if we learn that if they have a relation between x and y, then they can define the implicit differentiation, the rate of change of y with respect to x, which is minus partial derivative of f with respect to x divided by partial derivative of f with respect to y. Now, suppose you have more variables involved. Suppose you have the following scenario. You have x cubed plus y cubed. Let x cubed plus y cubed plus, let's follow the notes, z cubed plus 6xyz be equal to 1. Now we want to find the rate of change of variables with respect to each other. As you can see, these variables are attached together, and it's going to be very difficult to isolate one of them. So this relation is defined implicitly. What's the meaning of that? It means that we have a relation like f connecting x, y, and z together. Well, what is f? You can write down f this way. F of x, y, and z can be written as x cubed plus y cubed plus z cubed plus 6xyz minus 1 equal to 0. So you have a relation. Let us find partial derivative of, let's just working with implicit differentiation. Let us find the rate of change of y with respect to x, then find the rate of change of z with respect to y. These two, let's follow the formula. This is negative partial derivative of f with respect to x divided by partial derivative of f with respect to y. For the second one, you have minus partial derivative of f with respect to y divided by partial derivative of f with respect to z. Let us follow. This guy becomes minus, and on the numerator, partial derivative of f with respect to x, 3x squared. This is 0, this is 0, this is going to be 6yz divided by. On the denominator, we are taking the partial derivative with respect to y. This is 0, this is going to be 3y squared, this is 0, and this side is going to be plus 6xz. You can simplify this more by factoring out 3 minus 3x squared 2yz divided by 3y squared plus 2xz. Cancel out 3 and 3, you get minus. Well, you have x squared plus 2yz, and then y squared plus 2xz. The rate of change of y with respect to x, right? Now, what if you want to find the rate of change of z with respect to y? Okay, this guy becomes minus partial derivative of f with respect to y. This is 0, then you have 3y squared. This guy is 0 again, and here you have plus 6xz. Partial derivative of f with respect to z is going to be 3z squared plus 6xy. Again, you can simplify this more by factoring out 3. We get minus the y squared plus 2xz divided by z squared plus 2xy. Well, we can find the partial derivative of x with respect to z, z with respect to x, and so on. You can just follow the formula for implicit differentiation.